about the topics. So for last class, we have completed the nature of the flow, where we have seen the stream functions, velocity functions, and how to predict the flow, whether it is a compressible fluid, incompressible fluid, the rotational flow, right? Uniform flow. So last class we have seen all the types of the nature of the flow. Here in this class also we have seen how to satisfy the continuity equation, and from that also we have derived the psi and phi function. Psi means the stream function and the phi means is a velocity function. We have seen the categories that where the rotational follows and where the rotational flow follows. Now we will have some of the connectivity with the conservation of laws. So we have the three conservation of laws. The first one is the continuity equation, second is the momentum equation.
You are not audible.
I'm not audible?
Now audible.
Now audible? Okay. So there are three types of laws of conservation. Okay? Laws. The first one is the continuity equation, then we will have the momentum equation, and third was the energy equation. Okay? So when we talk about the continuity equation, what is the principle? That a mass enters into the system. Suppose we have any kind of cross-sectional pipe. Okay? So when the air enters, as per the figure given, when the air enters or the fluid enters, consider the cross-section of the pipe is A and the velocity is v2. Okay? And leaving from the cross-section A1, we have area 1 and the velocity at cross-section 1 is v1. So in considering the density of the fluid or the density of the air, dimension, that is ρ2 is equals to ρ1 equals to ρ. In that case, we can say that rho A1 V1 equals to rho A2 V2. So when we cancel out this rho, we get A1 V1 equals to A2 V2. Alright, and this explains, and this one only satisfies when the flow is incompressible. Okay, where the density is constant throughout the cross section. So remember this important formula, that is m dot equals to a1 v1 equals to a2 v2 only when the flow is incompressible. If they say that the flow is a change in flow, which we can write dot e. This is the actual formula for the mass flow. This is actual formula for the mass flow, and what is the unit? Kg per second. The unit is kg per second. Always remember the unit of mass flow rate. Now let's look into the formula. What happens when the flow is compressible? When the flow is compressible, there is a small derivations, but that is not important over here. But remember the final expression for an continuity equation for an compressible flow. So this is the formula: dou rho by rho plus dou v by v plus d e by a equals to 0. This formula represents the continuity equation for an compressible. This is for an compressible flow. Okay. Now the difference. This is only satisfied when the flow is incompressible. But here, this is for the compressible flow. So whenever they have given some couple of equations, and from that they ask you to find the continuity equation for an compressible flow, then this will be the answer. Now we will look into some of the derivative part. Now for a differential continuity equation, so here again you have to remember the differential equations. Okay, so you can see this formula over here. This can be also written as simplified and written as in this way. So there are a lot many equations that in various forms can be written. Okay. Dou rho by dou t equals to 0. And when the steady state considered, suppose dou p by dou t will tends to 0. Dou p by dou t will tends to 0. Then you will have only this equation. Now, next this is for the steady state. With the steady flow, that means dou rho by dou t will become 0. Now next, when we consider the flow is incompressible, okay, incompressible, we can write these rho 1, rho 2 to be same. Then we can write this way. So this equation is only when the flow is steady and incompressible. So then we can write this form. And the general differential form, we have to remember this. And this can be, that means that is del dot B represents that E dou x dou v by dou y and dou w by dou z equal to 0. And this one represents satisfying for the three-dimensional flow. And if they ask for the two-dimensional flow, what will be the equation? Dou u by dou x plus dou v by dou y equal to 0. So you have to be always alert with the types of flow. You have to be always alert with the types of flow. Okay. Now you have to also remember the integration form of the continuity equation. So from here you can expect they will give a uh, couple of equations, and from there you have to predict the right one. So you have to remember the final expression without any error. So also you have to understand what they ask, whether they ask the continuity equation based on the like uh, steady flow or incompressible flow, and what are the factors. Okay. Moving to next. So next, moving to momentum equation. Now what is momentum equation? It shows a principle based on force equals to time rate of change of momentum. So when we decide this time rate of change of momentum, okay, it represents that what kind of force first. It have a three different types of force. First we will have the body force, second we have the surface force, and third was the viscous force. Okay. Remember the principle, it depends on force equals to time rate of change of momentum, and when we have force, it acts three types: body force, surface force, and the viscous force. Okay, that means when we equate after the equation, we will get all the three different forces. Okay, so as you can see, this formula momentum equation for three different directions: x direction, y direction, and z direction. You can see you have to remember this formula again: x, y, and z. remember. And here you can see f of x. F of x represents our body force, okay, along the x direction. F of y represents the body force along the y direction, and f of z represents the body force along the z direction. This is a viscous force, you can see. And what happens with the surface force then? Which one is surface force? If this is a body force, viscous force, which one is the surface force? Surface force depends on the pressure acting on the particular system or a body. Okay? So this is the surface force. Alright. So they might ask you to identify the surface force and body force based on the equation again. So again, there is the integral form of an momentum equation. You have to remember that. Okay? So I am not going much deep with the derivation because here we don't need a derivation. Okay, but in fact you have to understand the equations for it. Now moving next, we will have the energy equation. Okay, energy equation. Yes, energy equation, again you have to remember the principle of an energy equation. What is the principle for an energy equation? Okay. Energy can neither be created nor be destroyed. It can only change its form. Okay. So you have to remember the principle again. Again the integral form and the differential form. So please note the key points here. We will have some change in internal energy will be acting into the fluid. Okay, change in internal energy. So here the main thing, as I've said, we have to remember the equations. Now we'll move to the main important part, given Bernoulli's principle. From there we can get a couple of questions. Okay? So remember, when we talk about Bernoulli's principle, first remember the assumptions placed in the Bernoulli's equation. The flow is always steady, continuous, okay, incompressible, irrotational. So these are the assumptions which you can see, and the velocity is also uniform over the section, and which is equal to the mean velocity. Then the acting force or the force acting on the fluid are only the gravity force and the pressure force. So these are the very key or the important assumptions. So they can give you a couple of options from that, and from there you have to find which one would be satisfying the right options. So you have to remember all the key 5 points. Alright. So is ideal. That means when we talk about ideal means what? That means no viscosity is present. Okay, keep that in mind. And when we talk about incompressible, that means density is constant. Steady means is also zero. The flow is streamlined and one-dimensional. This is also another important word. The flow is along the streamline. They might ask the Bernoulli's principle. They will give you the formula. They will ask you to find to predict that which dimensional it is. Dimensional flow, whether it's 1D, 2D, or 3D. So this is also one of the key points. This is a 1D. Then the velocity is uniform over the section and equals to mean velocity. Then the force acting is only the gravity force and the pressure force. Now one more point, the entire the, the summation of the Bernoulli's equation, as you can see, this is a formula for the Bernoulli's. Write the formula E1 plus that the potential functions, the kinetic function, the data function, all will be zero. And when we write about this is the potential energy, this is the kinetic energy, this is the data energy, will remain constant. Okay. So this is another, the summation of all the energies will become constant. This is one more assumptions for an Bernoulli's principle. Now we will see some of the problems of an Bernoulli's principle. Please to remember the formula. Okay. This one formula. Remember these key formulas. So this can be also written as a written P1 by rho 1 plus V1 square by 2 plus G Z1 equals to P2 plus V2 square by 2 plus G Z2. Okay. We have to use formula, and this can be also written as this one. This is only can be written, you can see here we have, can write rho 1, rho 1. So either of the equation is correct. So you have to remember the equation. Now here comes one question. Consider the following statement regarding Bernoulli's theorem for fluid flow. Okay. The first one, they have given conservation of energy. Second, it is a steady flow. Third is a viscous flow. And the fourth one is the incandescent flow. And they have given some of the options, okay, A, B, C, D. And in the A, B, C, D, they have given which of the following statement represents the correct options. Okay. So, can anyone unmute yourself and say that which is the correct option? Can unmute yourself?
Option B.
Yes?
B. 1, 2, and 4.
1, 2, and 4. Why 1, 2, and 4?
Because flow is inviscid.
Yes, very good. Because the flow is invisible, as I said. Because they have mentioned that the flow is idle. So this is the right answer. Alright? So you can expect such kind of questions. Moving to the next. Okay? They have given these are the questions under the Bernoulli's principle. Now one more thing. Okay, let me take you back. Now, how to differentiate the Bernoulli's principle problem and the problem which you have done in the thermodynamics of a steady flow energy equation? How do you predict between these two problems? How you can predict? Because there also you will have some kind of these terms, right? How will you predict, or how you can differentiate between the Bernoulli's principle, the problem based on Bernoulli's principle and the steady flow energy equation? How you differentiate that? You remember the steady flow energy equation, right? You had H1 plus V1 square by 2 plus Z1 decreased by En equals to, second half also will be same, plus theta by dm. How do you differentiate? Here also you have the velocity, here also you have the potential, here also you will have that each one can also written as in terms of P, right? In terms of pressure and internal energy. How you differentiate this Bernoulli's principle and this um, steady state equation, energy equation? Anybody can unmute and can speak. Any clue?
Ma'am,
How is the differential?
Ma'am, please increase your volume.
Sorry?
Volume. Your sound is not much clear.
But how you can find there is no volume factor, right? Here you have the velocity factor. There is no volume factor. There also you have this formula as I've written over here. This is the formula. How do you differentiate? Let me tell you, here when we talk about the energy equation, we will talk about the heat transfer. Okay, heat transfer, work transfer. We will talk about the enthalpy. Okay, H means enthalpy. But here we don't have any factor with the enthalpy. That's how you can differentiate it. Alright, know the difference. And whenever there are principles based on such kind of thing, you will get some kind of example like Venturi meter, orifice meter are the examples of the Bernoulli's principle. So this is another key point is in the word about the statement we have said in the question. We can identify the question belongs to which topic. Now let's look into the question. A Venturi meter of 20 mm throat diameter is used to measure the velocity of water in a horizontal pipe of 40 mm diameter. If the pressure difference between the pipe and the throat section is found to be 30 kilopascal, then neglect the frictional loss. The flow velocity is. Okay, so you have to find the flow velocity. That means first understand what they have given. So they have given the throat. So you know what the venturi meter looks like. Okay, so in the throat they'll be having 20. Then when the flow is entering the horizontal pipe, we have the 40 mm diameter. The pressure difference has been given, that is change in pressure has been given is 30 kilopascal. Then from there we have to find the velocity. Now first recall the formula. That is the formula P1 Q1 plus P1 square by 2 plus G is constant by Z1 equals to P2 Q2 plus P2 B square is G. Now what are the given data in front of you? What are the given data in front of you? So what is Z1 and Z2? What is Z1 and Z2? How you can find the Z1 and Z2? It isn't. It has to be.
Z1 and Z2 are the datum height.
Yes, is the datum height, and you can see in this figure both are in the line in the same horizon. And suppose the figure is not given to you, you have to consider that both are lying in the same horizon. That means Z1 equals to Z2. That means we can cancel off these two terms. We can cancel off these two terms. Now, can I write this equation in this way? It is P1 minus P2 by rho. Now rho is also not given, so that means it is the flow is constant. Let's consider the flow is constant equals to V2 square minus V1 square by 2. Can I write in this way? Right? Now how to find out this thing? V2 square minus V1 square. What they asked to find? They have asked to find the velocity of the flow. What will be the velocity of the flow? How you can relate? They have given the diameter. How you can relate? Can I use the continuity equation? Can I? What formula will I use if I use here? is E1 V1 equals to A2 V2. Can I use E1 V1 equals to A2 V2? Right? So please use this formula and tell me how this V1 is relevant with the V2. How the V1 and V2 are related with each other. Let me know. Tell me the answer.
Mom, in terms of area ratio, we can write, Mom. V1 and V2 can be written in terms of area ratio.
Yes, of course it can be. That's what I'm asking. What is the area ratio?
Okay, okay.
Ma'am,
Yes.
please increase your volume.
Am I not audible?
Not much.
Mom, actually,
Sound
Mom,
is
your
breaking.
voice is
Breaking.
your voice is low, Mom. Actually, the background disturbances are more, I guess, Mom.
Okay. Just let me
The noise level is pretty much more, Mom.
Okay. Okay, let me see.
Excuse me, Mom. Hello? Am I audible? Hello? Hello?
Hello? Am I better
Excuse me,
now?
Mom.
Yes.
Yes,
Okay.
Mom. Your voice is better, Mom.
Okay.
Mom, I've got one thing, Mom. A way like V2 by V1 is equal to 4.
All right.
And then I'm substituting in terms of V2 is equal to 4 times of V1 there. And then this
Okay.
side I'm having 30 kPa. And then divided by
Sorry.
1.225, I'll be getting the answer.
V1
Sorry,
equals
Mom.
to V1 equals to
It's
how
actually,
much?
Mom, it's 4 times of V1 that is equal to V2.
Okay. So you got this one,
Yes,
right?
Mom.
Okay.
Yes, Mom.
Now what you can do, we are going to, how you can find the other terms.
It's this seems to be simple, Mom. It's 30 kPa P1 minus P2, and then
Yes.
1.225, and then V2 is equal to 4V1. So 3V1,
Yes.
the squaring of that one will be getting V1, Mom.
Okay. So, and then what about the density? You know that this means it is how much? 30 kilopascal. Okay.
Density can be assumed to be sea level density, Mom.
No. See this question. The velocity of water in a horizontal pipe. So always you have to remember the
It's one,
density of
ma'am.
water. Density of water is
1000, ma'am.
1000. Yes.
Sure.
So
Sorry,
you
sorry,
have to give.
sorry, Mom. Sorry. I didn't see the water. Sorry.
Okay. So these are the things, minute things you have to look into the question. Okay. So in the question you have asked the 1000. They have said the water. That means you have to utilize the density is 1000 kg per meter cube. So when you solve that, let me know what is the right option you're getting.
Option D, ma'am.
Yes. So option, you will get the 2 meter per second. Okay. So you will get the 2 meter per second. Okay.
Yes, ma'am.
I hope all of you are getting the same. We will move to the next question. Okay. So what type of questions? The flow velocity is flowing through an tapping pipe having the diameter. Okay, we have given the diameter and another diameter for the section 1 and 2 respectively. So in that case, the figure is not given. You have to draw the figure by analyzing the question. Okay, so it is the, that is D1 is 300 mm and D2 is your D2 is a 150 mm. Now discharge through the pipe is same. They are given in liters, 40 liters per second. Okay. Then from the liters, discharge means cube. We have to make in terms of meter cube per second. Always be careful with the units. The section 1 is 10 meter above the datum and the section 2 is 6 meter above the datum. Now which one is the higher? Higher is the section 1. So look into the figure, they have given this is the section 1. Okay, this is section 1, this is section 2 and 6 meter above the datum. Find the intensity of the pressure at section 2 if that at the section 1 is the 400 kilonewton per meter square. So you have to find out the intensity of the pressure too. Okay. So how you can find? Can you find the same fashion? Can you utilize the same formula? That is P1, ρ1. Now what they have given again with a rho? Rho is a water. Rho is a water they have given. So always remember the density of the water is 1000 kg per meter cube. Then V1 square by 2 plus, here they are given the datum line, so you have to utilize this potential one, you can say potential or the datum energy. Okay. So like the previous one, what you can do, you have the diameter, you have the discharge. So from the discharge means A1, B1 equals to A2, V2. You can find out the individual V1, V2 value. Substitute over here. P1 is known in that. Now I can remember this is in kilonewton per meter square. Change the unit. Alright. Now question is how to change the 40 liter into meter cube. 40 liter into meter cube.
One meter cube is equal to 1000 liters, ma'am.
1000.
Liters. 1 meter cube is equal to 1000 liters.
Yes, 1 meter cube equals to 1000 liters. That means 1 liter equals to, can I say like that? 1 liter equals to 10 power minus 3 meter cube. Now tell me the answer of this V1, V2. What you're getting over here. What is V1 and what is V2 you are getting. Always change the unit, do not forget that. Any answer? What is V1? But tell me the answer for the V1 and V2.
I'm getting a very low value, ma'am.
Very low
Hello.
value.
Like V1 I'm getting 5.65 and 10 to the power of minus 6 I'm getting.
5 point
5.65 into 10 to the power of minus 6.
minus 6.
Ma'am, V1 is 42.44 meter per
Huh?
second. 42.44, 2.44.
See, do not forget the unit. Here we have in the diameter is in mm. We have to convert in meter. Alright? We have to convert in meter. Then here we have the 40 liters per second. That you need to convert from liters to meter cube. Alright?
Yeah, yes, ma'am.
So do not forget to change the units. Alright? After you find the V1 and V2, you just substitute in this formula. Okay? Substitute in this formula and let me know what is the P2 value you are getting. What is the P2 value you are getting? Hurry up and do it because you're taking a lot much of time. Exam you won't be having this of time. Right? So
Ma'am, even after conversion, all the correct units, I'm getting V1 as 0.5658 meter per second.
okay, tell me what is the P2 value you're getting? Are you
Okay,
getting
okay,
this
ma'am.
one?
Sure, ma'am.
Yes. Other in the chat box, and let me know in the chat box.
Ma'am,
Yes, please tell me.
V1 value is 0.1413 meter per second, V2 value is 0.571 meter per second, and finally V2 is 439.09 kilonewton per meter square.
Okay, so you're getting a different value, right? V1 is
So V1 is 0.1413 meter per second,
0.14,
13 meter.
Okay,
V2 is 0.571 meter per second,
0.57
1
per
meter,
second.
and finally P2 value is 439 439.9 kilonewton per meter square.
Okay, so
Point
that's
zero nine,
slightly
ma'am.
different.
439.09.
Okay, 0.09. All right. So
Kilonewton per
you're
meter.
getting, okay, yeah, that means you're getting closer to the answers, right? So that may be varying because of the G factor and other, minute factors. So others, please look into it. Are you getting the same answer?
Ma'am, can I tell the answer, ma'am?
Yes, sure.
Ma'am, actually, I'm getting V1 as 0.5658 meter per second, as I told earlier, ma'am. And V2 is 2.263 meters per second, and the final answer is coinciding with the slide answer, ma'am. It's 436.8 kilopascal.
436 point?
436.8 kilopascal.
Oh, you're getting the exact answer.
Yes, ma'am.
And what is the V1?
Sorry, ma'am. V1 is
What is
0.5658 meters per second.
the 56? Okay.
0.5658, and V2 is equal to 2.263 meters per second. No?
Okay. Please, I request all of you to check the answer, right? All right. But ensure the procedures. So if you do a small error in your problem, so based on the problem, you'll be having the options accordingly. It will be there. Okay. So ensure your units before solving. Okay. Ensure your units. So so those have not completed, keep that as a task. So you can practice this question once again. Alright. So again I'm telling, ensure your units before you do or solve any problem. Now we will move to the next very very important another applications. Okay. It is an application as I have given a slide I think introduction about the application. I request all of you to mute yourself. Thank you. So already I've given the brief introduction about this subsonic wind tunnel, what are the important parts. So when we'll go more in deep in the wind tunnel when we look into the a separate topic is there about wind tunnel. So here we are just going to see how this Bernoulli's principle and combination of continuity equation play a very important role over here. So they have considered this a settling chamber. Okay, here we have the settling chamber. This is the nozzle. This is the dissection. Okay, and here we will have the diffuser. Now, let's consider the, the air entering into the wind turbine, wind tunnel is V1, V1, A1, and when it's entering into this section is V2, V2, and A2. Okay. Then contraction ratio. Okay. Contraction means the area between the settling chamber and the nozzle to your test section. And from there you have to understand the always the contraction, the T is always greater than A2. Keep that in mind. The A1 is always A2. Okay. Now, here how they get the question, here we measure this using we have the manometers. There are lot many types now. It can be a digital manometer or the old manual kind of manometers with it. Using that we measure the pressure difference. Now there is a formula how they ask the question. Again, here they ask the question either by find out the change in pressure, or you have to find one of the velocity. Okay, either the intake velocity or the velocity at the test section. So what you have to do is you have to remember this very important formula. Okay, that is V2, that is a velocity at the section equals to twice of V1 minus V2, okay, to rho 1 minus A2 by A1 square. And this can be also written as this way. When we are writing P2 by P, P1 minus P2 can also be written as twice rho G del H, okay, rho. This is the rho when we are talking about the this is a very important formula. Okay. And keep that in mind when we are using this rho is the density of the mercury. This one is the density of the free stream or the air. Now the difference. Do not get confused. Okay. This is the free stream. I hope you can see I'm writing the integration, like writing the infinite sign that represents is a free stream one. I hope my full screen is visible. Whether my full screen is visible?
Your screen is visible, ma'am.
Alright. Alright. So please note down the formula. Okay. So from there you can also can be write in terms of V1 then. Now this is we know that is V2. V2 is for the test section. Okay, V2 means is a point of test section. Now from there can I write a V1? Then what will be the V1? What will be the V1? What will you do if they ask about the V1? So first use the V2, you know this is the formula. Again you know A1 V1 equals to A2 V2. You know this formula. Okay, V2 is this one. A1 A2 is known, that is the contraction issues. From that you can find what is the V1 from here. Okay, so if they ask the relation, how can you find? If they ask the relation, can you see my screen now? Now what is the formula I said? equals to 2 P1 minus P2 by rho 1 minus A2 by A1 whole square. Okay, only this one square. A2 by A1 square close the bracket. Now what I have said that from here how do you find V1? Okay. Now remember now A1 V1 equals to A2 V2. Alright. Now your requirement is to find V1. Then from there you can write is A2 by A1 into V2. Now what is V2? 2 by A1 into is twice of minus V2 1 minus A2 by A1. Can we write like that? Can we further simplify this equation? Can we further simplify this equation?
Ma'am, A2.
So, A1 minus B2 by rho. So, can I write A1 square minus A2 square thereby A1 square? Okay. So, can I take this instead of over here A1? Can I write 1 by A2? Can I bring down this term over here? Can I? So, twice of. So, how you can simplify this equation again? Do you find any other better solution than that? Simplify this equation.
As told already, like A1 by A2 is given a ratio, so that can be used.
A1 by A2
Is a
the ratio.
is a ratio, is a contraction ratio.
Yes. But here we have this complex terms. How we can use that? So can we write this A into A1 by A2 again? That one minus of this the same way. The same way we can write. Can we?
Yes, ma'am. Actually, ma'am, the step before this, like expanding that A1 square minus A2 square by A1 square, I think that could have been avoided, ma'am.
That can be avoided and we can make to this equation,
Yes, ma'am.
right? Okay.
Yes, ma'am.
The
That
main
would have been
motto is
simple.
you have to remember this one also. They might ask in this form, right? So that's the main motto
Okay.
of expanding. Okay, that is the main motto of expanding. Either they can ask in this form or they can ask in this form. Okay, so remember the final expression, but this is much more complicated. So I will request all of you to remember this equation. Okay, remember this equation, that is V2 equals to twice of P1 minus P2 by rho 1 minus of A2 by A1 whole square. Okay, only this one is whole square. Close the bracket. So once you know this V2, you can derive the V1. Now in that case, suppose they have asked you to find out the V1. So you will able to know or how to find out. Okay, that is another method to find out. Alright. Now we will go back to the previous slide.
What is the denotion of the contraction ratio, ma'am?
See, the main meaning is the A1 by A2 always it should be having a high value. So sometimes there are some problems or in the statement they are giving the contraction ratios and they are giving like suppose 1 by 15 or 1 by 20 kind of value. So you have to understand from there that if this 1 by 20 that means it is a A2 and this is A1. By using the value you have to understand that what they are trying to represent. Okay, but main thing when they are using the vocal contraction is a intake area or you can say the area of an settling chamber to the area of the test section. Now we will get to one of the problems. Okay, here you can see the formula given. Now this is one of the problem. Okay, so let's solve that. Alright. Now consider a low speed open circuit subsonic wind tunnel with an inlet to throat area is 12. The tunnel is turned on and the pressure difference between the inlet, that is the settling chamber, and the test section is rated as a height difference of 10 cm on the U2 mercury manometer. The density of the liquid mercury is 1.36 into 10 power 4 kg per meter cube. Calculate the velocity of the air in the test section. Okay, so this is the question we have given. So that means velocity of the air in the test section means as per the diagram which is shown, it has to find V2. So what is V2? Twice of P1 minus P2 by rho 1 minus A2 by A1 by 2. Now, sometimes you might have a confusion that how to remember it is a A2 by A1. Okay, so there is one way. If you remember that, when you're writing this form, this both the two will be here. Both the two will be in the upper part. So that's how you can avoid the confusion. Of course, you'll be practicing, but the practicing also, if you remember in this way, it will be easy for you. Of course, it is not a whole square. It is A2, A1 whole power 2. Okay? So both the 2 will be in the top. I hope if you remember in this way, it will be much easier to remember. Now here in this they have given what are the given factors? They have given the intake and the throat. That means they have given A1 by A2. A1 by A2 is 12. Then what they have given the difference height. That means they have given we have to utilize the another formula. What is the formula we have to use? Rho of mercury into G into del H. That means del H is given, that is a 10 centimeter. So since it is centimeter, we have to convert in terms of meter. Okay. So how will you convert? 1 meter equals to how much centimeter? 1 meter equals to how much centimeter? Let me know.
100, ma'am.
100 centimeter, right? So that means 1 centimeter equals to 10 power minus 2 meter. So 10 power minus 2. Okay. Now moving to the next, that what is given density of the liquid, density of mercury is given, which is given, and from there. So this the factors is known. Then here of course what they have given, density of air. right? This is the density of the air. Now here, since it is the density of the air, what is the density of the air? If you remember what is the density of the air? 1.25. You can also take 1.23 also you can take. Okay. Remember the density of the air is known. Then 1 minus A2 by A1 means 1 by 25. Right? You solve and let me know the answer. Let me know the answer. This is the phase stream of the air. This is for the mercury. G is 9.81. Del H is 10 into 10 power minus 2. And from here you can find the V2 value.
Excuse me, ma'am.
Yes, please.
Ma'am, is then in the formula itself it's A by 25, ma'am?
Yes,
Okay.
A by 25 means, see the question, they have given the inlet to throat. That means, okay, the inlet means A1, throat means A2. That is a test section. They are not telling the test section, they are telling the throat. So if you look at the diagram, what is the throat? Throat is the test section, right?
Yes, ma'am. Yes, ma'am.
Okay. So this is the throat. Okay, this is the inlet. All right.
Okay, ma'am.
So please understand and the question carefully. So tell me the answer. What is the answer?
Ma'am, actually,
Yes.
is that the... Can you just tell me the second formula once, ma'am? I'm not getting it.
Second formula in the sense, this one. See, the change in
Yes, ma'am. Yes,
pressure
ma'am.
as rho g h. Okay, rho g into del h.
Okay.
Okay,
Okay,
from the
ma'am.
Pascal's law. Okay, but here we are not
Okay,
dealing
okay,
with
okay.
Pascal's law. So, but this concept came with the Pascal's law. Change in pressure equals to rho g del h.
Okay, okay, ma'am.
So I hope all of you got the answer. Let me know the answer. What is the
Ma'am, will you
answer?
please tell me how this, ma'am, will you please tell me how this contraction ratio comes out to be 1 by 25?
1 by, oh sorry. Okay, sorry. It is 12.
Ma'am,
Sorry.
answer is 219.79.
Sorry. Answer is?
219.79.
Okay, 79 meter per second. Okay. So
Yes,
by
ma'am.
secondly I put 25. Okay. So here they have given 12. So it will be 12 only. Okay, not 25. Thank you for telling that. So I hope all of you got the answer. Can we move to the next? Okay. So yes, to understand that, one more important factor is the dynamic pressure. Okay. So remember the dynamic pressure that is represented in terms of Q. Okay. So Q equals to half rho V square. Now this half rho V square satisfies for the all the fluid. Okay, all the flow, including starting from the incompressible to the hypersonic. Please remember that this dynamic pressure half rho V square, it satisfies for all the fluid. And then from there, how to find out the total pressure? The total pressure is a summation of the static pressure plus the dynamic pressure. Now why we have to understand that? Because we have to obtain a coefficient of pressure. Okay? So the coefficient of pressure either in terms of the pressure or in terms of the velocity. So okay, now so that's why we are looking into the dynamic pressure and the what is the effect of total pressure. Now dynamic pressure can be written in this way, as you can see over here, Q equals to P0 minus P1. Now what is P0? P0 is the total pressure. Now what total pressure? Total pressure is also called as a kind of stagnation pressure. Now when the stagnation pressure occurs, when we use the word called stagnation point. What is stagnation point? What is meant by stagnation? It is a very, very important thing to understand. What is meant by
At which flow comes to rest?
Yes, at which the flow comes to rest, that means the velocity becomes zero. The velocity becomes zero. So okay. So how do we find the mm, that which instrument we use to find out the stagnation points or stagnation parameters? Which
Pitot probe,
instrument
ma'am.
we use? Yes, pitot static tube. Okay. So where it is kept in the pitot static tube? Where do we keep the pitot static tube? Where we keep? In the wing or in the fuselage? Where do we keep?
Ma'am, in the nose section for fighter aircraft.
Yes, we
Below the nose section, ma'am.
yes, below the nose. It depends again with the aircraft. Okay, so mostly we prefer to keep in the nose section of the fuselage. So mostly we keep the nose section of the fuselage. Okay. So to identify the what is the velocity, so we use lot many kind of instruments to predict. Okay. Now we will come again when we look into that kind of we will be studying with the instruments, flight instruments. We will again come to this kind of point. Okay. So alright. Now remember this formula. That is a dynamic pressure can be written as the total pressure minus the static pressure. Okay. Now, now there is another important thing to understand. What is the coefficient, pressure coefficient, or coefficient of pressure? This is the formula. Okay. So most of the time we get confused at how to remember this formula. Okay. So P naught means whenever the question will be given, P naught will be always the reading or the measurements. Okay, measurements from the pitot tube. So that will be the P naught value. Okay, I'm repeating again. P naught is a measured value or the reading. If they won't say that this is a total pressure has been obtained, never they will utter this word. They will always say the measured value or the recorded value or kind of reading in that any instruments. They'll be using that word. That means from there you have to identify that what is the value. That means it is a P naught value. Okay, and the other the free stream pressure, if they're mentioning, that is the P infinite. Okay, that is the value. And of course the rho Q infinity is the half rho V square. Okay, so using this formula we can again rewrite the equation in this Cp equals to 1 minus V by V infinity whole square. Please do remember this formula. Every year they are asking one of the other questions from this topic. Whatever we have said, that either the questions from the wind tunnel or from based on the concept of the pressure coefficient. Every time they are asking 1 marks from here. So do not forget the formula. This is V by V infinity. Okay, V by V infinity. V infinity is a free stream velocity. Okay, and this formula is only satisfying for the incompressible flow only. This is only satisfying for the incompressible flow only. Now, in case, as we said, that if you want to satisfy this in the Bernoulli's equation, okay, considering both the data is constant, both the Z1 and Z2 is constant, in that case, if the velocity, that is Vd, is coming to an rest, Vd is coming to an rest, in that case we can write that Va or V1 equals to root over T naught minus Ta divided by rho. Okay, this is the rho. So remember this formula also. There are also not many questions they ask from you. Now one more thing you remember that in GATE, whenever they are asking the questions for 2 marks, whenever they are asking the question for 2 marks, they always have to use a couple of formulas. Okay, you have to use 2 formulas. Okay, so I think you have seen the last few days, right? Either you have to use the mass formula, that is mass equals to density into volume, that formula, or any other formula you have to use. Okay, so to find out any other parameters. So remember, we don't know, they won't be asking a direct question. You cannot expect to get a direct question. Always there will be an indirect question. Put that in your mind. Always they will ask an indirect question. This implementation they might ask in some other question. Maybe this kind of concept they might ask in flight mechanics to find out some of the value in the instruments. Okay, so please be precise, have the clear idea where you can use which formula. Okay. So again, in the further topic, when we will see more into the thermodynamic parts, and we can compile the isentropic process which we are studying in aerodynamics, how that formulas are going to implement in the propulsion also. Okay, we will see that also, that kind of problems. So please remember the formulas carefully. So you create your own kind of notebook, and from there you will start noting down the formula. Okay. Alright. Now similar to that, we have one problem. Okay, let's look into it. Consider the one aircraft cruising at the standard altitude of 4 km. The pressure sensed, see they have used the word called sensed by the pitot tube on the right wing is they're given the value. This is the 10 power 4 Newton per meter square. At what velocity is the aircraft flying? Now assume that the aircraft is flying at sea level, then at which velocity must it fly at the sea level to experience the same dynamic pressure. Okay? So they have given 2 things to find out. The first thing, they have said the aircraft is flying at an altitude of 4 km, and from that we have to find out what will be the velocity of the flight. Okay, that means what will be the velocity of the flight. So using that, let's see, they are given at the 4 km altitude what will be the static pressure, and the density has been given. Static pressure and the density is given. So we have to utilize the formula which we have seen this before. That is V1 equals to root over 2 P naught minus P1 by rho. Okay, rho at what altitude it is flying. That we have to use rho at which altitude. P naught will be the, as I said, the measured or the recorded, or here they have used the word called sensed. That means sensed by pitot tube. Okay, so that value we have to substitute over here instead of P naught. Minus P1 is the static pressure you have to use during the 4 km, right? Now if instead they are using the sea level, if they are using the sea level, that means you have to use the sea level pressure. Okay, since they have given the record for 4 km, we have to use for the 4 km altitude what is the free stream pressure. Okay, When you solve, you get the answer. Then what is the next? They have said that now assume that the aircraft is flying at the sea level. At what velocity must it fly at the sea level to experience the same dynamic pressure? Telling the dynamic pressure at the 4 kilometer will be same as a sea level. So for that we need to find out the dynamic pressure for the 4 kilometer. Or we can find yes half rho v square. Okay. Now v for that when it is in 4 kilometer. The velocity for the 4 kilometer you are going to substitute and the density for the 4 kilometer or for the 4 kilometer you are going to substitute to find out the dynamic pressure at the 4 kilometer. Now you got this. Now as the question said that it will be same as the sea level. That means this is equivalent to the dynamic pressure for the sea level. Now from this condition what we have to find is that what will be the velocity of the flight. Now again recall that equals to half rho at the sea level. This is a general formula. You know the density at the sea level. You know the density that is 1.225 or you can use 1.23 value. Substitute that and you get the answer. You got this problem statement? Is that clear to all of you? Let me know. You can unmute and can say if you got this statement. So,
I got it.
once again.
I got it, ma'am.
Okay. So I hope all of you get it. So keep that in mind. Again, after the completion of the lectures, it will be maybe by tomorrow it will be posted in that platform. So you can recap that again. So if you have any issues, you can let me know. All right. So now, similar to that, we have one more problem. Okay. Consider an airfoil in a flow with a stream velocity of 45 meters per second. The velocity at a given point on an airfoil is 38 meters per second. Calculate the pressure coefficient at the point. Okay. They have given the velocity. They have given the velocity. Now consider the velocity of the stream velocity. Okay, free stream. That means it is V infinity is 45 and the given point is V. Calculate the pressure coefficient. Now can you tell me what is the formula? Pressure coefficient written as Cp. What is the formula? 1 minus V by V infinity whole square. I hope I am right. Let me know. Let's check the formula. Let me know whether I've written the formula correctly or not.
Yes, ma'am. It's correct, ma'am.
Okay. So how I remember is I remember the infinity term will be in the denominator. Okay, in the bottom. Okay. So I know the other term will be in the top. So this is how I used to remember this formula. So 1 minus V by V infinity. So I know the factor 1 minus V is 68 by 45 whole square and solve and let me know whether you are getting the same answer or not.
Yes, ma'am, we are getting it. Minus 1.28.
Minus you are getting minus 1 point. Are we getting minus?
Yes, ma'am, I'm getting it.
Okay. So this is can we have 1 mark answer? Okay, as we have explained this, yes, similar to that kind of problem, we have another thing. A pitted tube on an airplane flying at standard sea level reading is 1.07 into 10 power 5 Newton per meter square. What is the velocity of the airplane? Now from here you have to find the velocity. Right? You have to find out the velocity. Now what they have given is a standard sea level reading reading they have given is 1.07. What it is? What they have given? What is the formula?
They've given the P naught value, ma'am.
Yes, P naught minus P static by rho. Right? This is a formula. That means if I given the P naught value, then what is PS? 1.
The sea level pressure 1.0325. 1.0325, ma'am.
0. Now you substitute the value. 1.0125. Okay. This is in. Now what is the density rho value? See, I request all of you already have discussed about this gate virtual calculator. Please do install in your computers or laptop, right? Do not use the programmable calculators because that will be quite different than the virtual calculator. In program calculator, it will be much easier and compared with the virtual calculator. The systems are quite different. So please get accustomed with a virtual calculator. Okay? So again at the end of the session, I will again share the link with you. So please do install and use that. Use that app.
110.65, ma'am. Meters per second. 110.65 meters per second, ma'am.
110.
Yeah. Yes, ma'am.
I'm getting 196.
Ma'am,
Sorry, ma'am, I didn't get you.
78.25 per second.
Sorry?
78.25 meter per second.
78.
78.25 meter per second.
You get this answer? See, remember what is the value? 1.0135. Okay? Or you can also take this value 1.013 in 10 power 5 meters. Please ensure that answer. Because I'm getting 90 point something.
Yes, ma'am. It's 78.246, ma'am.
38 point. You're getting the same answer. Good. Let me calculate once again because I've got a different answer. First, we're getting 1.07 minus we have 1.013 into 10 power 5 into 2 divided by 1.25 because it was 9306 right? Power 1. I'm getting 96.46. Yes. B was to root over 9306.1. Is the same value? Ensure that whole root over.
Yes, ma'am. 96.25.
Yes, near about that. Okay. Now from there, if they have asked you to further to find out the coefficient of pressure, for example, if they not suppose they ask you to find the coefficient of pressure. Now what is the formula? Here you know in terms of pressure is P V square. So can you find out the answer? P naught is 1.07 into 10 power 5 minus Ps is 1.013 into 10 power 5 half into 1.5 into velocity is 96.47. Calculate and let me know what is the answer you're getting.
Ma'am, it's one.
You're getting one. That's plus or minus.
Ma'am, CP is 1.
Yes, that's what my question is. It's the plus 1 or minus 1. It's just
Ma'am,
1.
positive 1. Plus 1. Plus 1.
Yes.
Yes.
So sometimes in the question they might confuse me with a plus 1 and minus 1. So always be ready with the things. Okay? Clear? Okay. Let's move to the next. Now, so till now we have completed the observation of laws and whatever we have continuity, the vulnerability principle, CP factors, dynamicity. Now the next phase we have is in dimensionless numbers. Okay? So in the dimensionless numbers, you have to remember what the dimensionless numbers are there, how to find already you guys know. So you should also understand that what are the kinematic functions and the dynamic functions. So I also have multiple functions you can see. Okay. So where we will have the force, and the dynamic field, we will have something with the velocity or in motion. We say as a kinematic. Okay. Then we represent something in terms of dimensions. We call it the dimensional one. So dimension of three types. One is an geometric, kinematic, and dynamic. So as I said, geometric is a word you can understand. It will be representing based on the geometrical properties. Okay. Then second one is kinematic, based on the motion of the fluid or motion of something. Then third one is a dynamic, when we have the force indulged into that particular system.
Excuse me, ma'am.
Yes.
Ma'am.
Yes, yes. Please let
Ma'am,
me
your voice is being broken in the middle, ma'am. I'm not able to listen actually.
know. Okay.
Hello.
Yes, yes.
I could not understand the dynamic quantities. Sorry, ma'am. Can you tell it again, please?
Yes, yes. Let me know whether now I'm audible or not. Am I audible?
Yeah. Yes, ma'am. Now it is audible, ma'am.
Okay. So there are three factors. Now, the study. Dimension numbers. Okay. There are two forms. First one is geometric, is a kinematic, and third one is the dynamic quantities. Okay. Geometric means when we define some kind of length of anything or the area of something or volume of something. So that time we define the geometry, how it looks like. Kinematic we represent in terms of motion. The name itself is understand kinematic. We need to look at motion. Okay, maybe when we represent the velocity of the fluid or the acceleration of the fluid or the discharge of the fluid, so we represent the kinematic one. Dynamic means when it represents that any kind of force exerted in a body or some kind of stresses undertaken by a body, right? Some other means of force or some kind of stresses acting on a body, we call as a dynamic one. Okay. So, for an example, force, surface tension, okay, shear stress will come under the dynamic. When we talk about dynamic, discharge, okay, discharge, then velocity, angular velocity, accelerations, angular accelerations, geometric means area, volume, and so on will come under. Now, when we begin with the dimensionless number, you have to understand about the dimension homogeneity. Okay, that means if we have some equation called force equals to mass into acceleration. Okay, that means the both sides it has to be a balance. Both sides it has to be a balanced one. Alright, so both has to be a balanced one. That is the mean by the dynamic. That is the mean by the homogeneity. Okay. Now, what we can understand from this homogeneity, suppose what kind of questions you can expect from here. Now, suppose in this question they are asking you that they will give you some function, okay, maybe for an example, considering this way, Reynolds number is given. All of you know what is the Reynolds number, okay, what is that? Rho by mu. Okay. Now, this is also the equation. We can say it is a dimensional homogeneity. Homogeneity means both. If I equate this only on the right hand side, I will be getting no units. And if I Reynolds number also have no units. Here in the force we know it is a Newton. When we resolve that in terms of in the F into A is also going to get the same unit. But in the question how you can expect they will give you some kind of typical different types of in the question or in the options. So from that you have to find out the odd one out or maybe the right factors. Okay. So using the homogeneity function. So what you have to use it, you have to find out the units for the particular component and you have to figure out that what they're trying to and ask you to find. Okay, so that is the implementation of the dimensional homogeneity. You have to equate and find. Now how you can equate? Now if I talk about this Reynolds number, how I can do? What is the Reynolds number equals to dV rho by mu. Now I know all the units of over here. What is the unit of d, that is the diameter, is in meter. Now what is the velocity is meter per second. Now what is the unit for rho, that is a kg per meter cube. Right? Then mu, Newton second per meter square. Now when I resolve, if I try to resolve these factors, then all the factors will get cancelled out. Now let's see meter, if I write meter square by second into kg into meter cube. Newton means what we can write? Kg meter into second square, right, into second into again meter square. Now can we cancel out the terms, all the terms? Here we have the second, here we have second square, here second got cancelled out. Next, we have another terms called meter square, here meter square, here we can get cancelled out. Here we have kg, kg. So we are getting 0. That means it is equal to M0, L0, T0. And here also we have M0, L0, T0. So this is called as an homogeneous. I hope you can see that. Can you see my screen that I'm writing? I hope you can see. You can unmute or you can write in the chat box. I hope you understood what is meant by the dimensional homogeneity. Okay. Can you see my screen?
Yes, ma'am, we are able to see it.
All right, thank you. So this is one of the concepts. Next thing is, right, there are a lot many functions that you have to remember. Okay? Now let me once again share my screen. So there are two methods. Okay. So two methods of finding out the dimensional analysis. Okay. The first one is that Rayleigh's method, and the second one is a Buckingham Pi method. So here, what kind of questions you can expect? Let me tell you. So again, here the same. Here they are not going to ask you to solve or anything, but yes, they will ask you. They will give you the statement. So from the statement, either you have to identify the statement is right or wrong. Okay, and what are the advantages and disadvantages from this particular method? They can also ask from this method. So Rayleigh's method, the limitations of the Rayleigh's method that it cannot go for or it cannot find the relation between more than three variables, more than three dependent variables. Okay, suppose there are four variables. Okay, the x1, x2, x3. You can see here. Let's consider these are the dependent variable. That is, these are the dependent with x variable. So we can write the function like x equals to function of x1 to x3. So it is hardly can interrelate with this factors. It cannot. If I have one more factor called x4, that means I cannot use the method of Rayleigh's method. Okay, the Rayleigh method otherwise it's a very simple method. Okay, but the only limitation is it can limit it to hardly it can find uh, of three dependent variables. Okay, but Buckingham Pi theorem, that is the most advantageous one as compared with the Rayleigh's method. It is irrespective of the number of variables. Okay, either it can be a dependent or independent. Irrespective of that, it can able to find out the relation between the n number of variables. Okay, so there are some kind of arrangements that Buckingham Pi theorem follows. What it says, suppose if there are of n number of variables, okay? If there are of n number of variables, let's consider it can be of independent or dependent. So how to arrange this kind of n number of variables is that n minus of m. Now what is this m? M is the fundamental dimensions. Okay, m is the fundamental fundamental dimensions. And what is meant by fundamental dimensions? M, L, and T represents as a fundamental dimension. That is, M is always constant. That is 3. M is always constant. That is 3. That is M1, L1, and T1. So M becomes 3. So how we can make an arrangement into the n minus of n dimensionless groups. Okay. So if we have lot many factors, suppose an n number of factors, that is x1, suppose any one of the factors x1 equals to function of x2, x3 and till xn, then it can be converted into a dimensionless number that is called as the pi term. And how to align this pi term? Pi term will be equivalent to an n minus of m term. Suppose we have the number of component is suppose 5. We have 5 variables, that is n equals to 5. Alright. Then how many pi terms will we be having? We will be having 2 pi terms, that is pi 1 and pi 2. How I am telling? Because based on this fact is a pi minus 3. Pi minus 3 is 2. That means we will have the 2 pi terms. Got my point? Let me please unmute and say that you got the point. Or you can use the chat box.
Yes, ma'am, we are getting.
Alright. So, actually, I'm speaking loudly only. I don't know why that problem is happening. Okay, let me check in this way. Just let me know whether you are able to hear in a better way or not. Are you able to hear in a better way? Use the chat box to respond.
Actually, mom,
Able to hear in a
mom, there's some noise along with your voice, mom. There's some sort of signal disturbance. Am I audible, mom? Hello?
It's better than
Hello? Hello?
previously? Yes. Is it better than previously?
Yes, ma'am, now it's better, mom. Now it's a little bit audible.
Okay, okay. Okay, very soon I will fix this thing that why my voice is not audible. Let me look into that issues also, okay?
Sure, mom.
So let me repeat a bit over here that Buckingham Pi theorem says that yes, it will have the most advantageous thing over here is we will have the n number of variables. Okay, it can be either of independent or the dependent variables, and this number of variables it can be any number. N can be of any number. Like Rayleigh's method, there was having some constraint. Okay, but in Buckingham Pi theorem, it is of irrespective of any kind of variables. It can go to any extent. Now, how to make this arrangement? It can make the arrangement based on n minus of m, which is a dimensionless group, which is defined as a pi term. Defined as a pi term. Okay. Now, what is this n minus m? M means is a fundamental dimensions, that is m, l, and t, which is represented as 3. Okay. Now, suppose as a given an example, if we have the n is equivalent to 5, if we have the n is equivalent to 5, that is, we are having the dependent and independent variables of 5, total 5. Now, what will be the number of pi terms? Then the number of pi terms will be our 2. How? Because n minus of m, that is n is 5, m is 3, is 2. That is, we will have the 2 dimensionless pi terms, that is pi 1 and pi 2. Okay, so they will give you the questions and they will ask what will be the questions you can expect. Now, apart from that, you have to remember few of the very important numbers. This is very important to understand the numbers. Okay. So what are the numbers we have? So first we have the Reynolds number, Faraday number, Mach number, Cauchy number, Weber number. So these are the topmost important, very important. But apart from that, we will have some more numbers. So here I am sharing that we have to remember these are the numbers, very important numbers. So first we have the Bingham number. So this Bingham number, you have to remember the definition and the formula over here. Okay, you have to remember the definition and the formula. That is very important. They will ask the question based on that. Okay, so Bingham number is the ratio between the yield stress versus the viscous stress. Okay, this is the formula of the Bingham number. So tau represents the shear stress, L is the length of the plate, mu is the viscosity, dynamic viscosity, and B is the velocity. Okay. Next number is a Biot number. It is represented as Bi. So let's see what is the formula. Bi equals to HL by K. This is a K, okay? K suffix C. K suffix C means okay, let's see one by one. H is a conductive heat transfer coefficient. Conductive heat transfer coefficient. L is the length of the plate. K is the thermal conductivity of the plate. Okay. Alright. Remember the formulas. That is very important. I'm telling you repeatedly. Then we have the Euler's number. Euler's number represents the change in that is a pressure force divided by the inertia force. Okay, this is a pressure ratio between the pressure force and the inertia force. It can be also represented as V by, that is the velocity, by root over pressure by density. Okay, pressure by density, or it can also be written as V by of rho by P. It can also represent that V root over rho by P. Okay. This is the Euler's number, which represents the ratio between the pressure and the inertia force. Faraday number, it is a flow inertia with the gravity, or we can say Faraday number is a number where it has an impact of a gravity, or you can say it is an effect. It plays a very huge effect on the role of gravity. So again, it is the ratio between the velocity versus root over gravity into the length of the plate or length of the plate. Next is a Toothsen number. Toothsen number is a very unique number. It depends on the how the flow pattern takes place in the effect of heating. Okay, so mostly we don't study this Toothsen number in our academics, but it play an very important role. It is a ratio between the, you can see the Mach number versus Reynolds number with respect to the ratio of the specific heat. Okay, please do remember the formula. On the same time, in this side you can see, you can expect this kind of question. They will give you that pick which one of the following satisfies the slip flow might be. So it ranges between this. If the Knudsen number is between 0.01 less than the Knudsen number, and within this factor, that is, it should be ranging between 0.01 to 0.1. That is, in this condition, we will have the factor of the slip flow. Okay, if this is a transitional flow, then it has to be between 0.1 to 10 Knudsen number. If it is a free molecular flow, then it has to be greater than 10, and less than 0.01 will be the continuous flow. Okay. All right. So you have to remember the Knudsen number quite well. Then we have the Nusselt number. Nusselt number, it's a ratio between the conductive heat transfer by the conductive heat transfer. Again, we have the ratio between the HLK. It is also, H means conductive heat transfer coefficient and K is a thermal conductivity. Then very important one is a Prandtl number. Another very important one. There is a lot many applications based on this number, Prandtl numbers. Okay, Prandtl number is a ratio between the specific heat, or you can say the momentum diffusivity by the thermal diffusivity, or we can also recall that in Cp into mu by K. Cp is the specific heat at constant pressure into the dynamic viscosity by the thermal conductivity. Okay. Next we have the Prandtl's number. Now Prandtl number also will represent, we will look into the factor when we'll go for the boundary layer theory. So there also it play a very important role. Remember, the Prandtl number of the air is always 0.71. Remember, the Prandtl number is 0.7. Next we have the Reynolds number. Always we know it plays a very important role in the field of aeronautics. So it's a ratio between rho VL by mu, where V is the velocity, L is the length, rho is the density of the fluid, mu is the.
Excuse me, ma'am.
Then we have Strauss number. Yes.
Am I audible? Hello.
Yes. Continue.
Excuse me. Ma'am, may I know why the value of Prandtl number is equal to 0.71? How
the
hello?
Prandtl number become? Yes, 0.71.
Why the value of 0? Yes, ma'am. Why it is 0.7?
Yes,
I
it's a
don't understand
constant
that.
value. There's a constant because specific heat at constant pressure will be same. Viscosity of the air
Yes,
is
ma'am.
same. The thermal conductivity of that same. Then when we substitute all the values, we will get 0.71.
I didn't hear you properly, ma'am. K is the thermal conductivity of
Thermal conductivity of the property air. Here, if you find
air.
air,
Okay.
this is what see thermal conductivity. Okay, this is the thermal conductivity. If whatever the
Okay.
component we are finding, so based on that, this property will change, right? So when finding for
Sure,
the
ma'am.
air, then accordingly we will get that. All right?
I got it. I got it, ma'am.
Okay. So comes to the Straussian number. Straussian number is another important number. Okay. I hope many of you have studied and done some projects on that Straussian numbers. It is a ratio between you can see the frequency of the vortex shading into the length by the velocity. Okay, so when we will see the turbulency in any component, or that means it will have the particular object will leads to some kind of increase in frequency. That time we can utilize Straussian number. Okay. Now Weber's number, it depends on the surface tensions. Okay, it depends on the main factor of the surface tension. It's a ratio between the drag force by the surface tension force, can be represented as V by root over sigma rho L. Okay, so it can also be written as this way, rho L by sigma. Okay, can also be. Now, all right. Now we will have another three types of similitude. Now, before going to similitude, I request all of you to please go through with these numbers. Okay. So, evening class we are having another session 6 to 8, right? Evening 6 p.m. to 8 p.m. we have the session. That time we will undergo the problems at the similitude. Before that, keep that in mind. Here we are going to the model and prototype. Okay, model and prototype. Now what does model and prototype refers? Model means some kind of model. Okay, that kind of scale down model, we can say a scale down model. Okay, the model means. Prototype means actual component or actual product. So here we are going to deal with a model and prototype. So you can expect one of the questions from this topic. This is a very important topic. They ask one question based on the model and the prototype. Okay, so prototype means it's an actual product. Suppose we have some kind of aircraft we are designing and we have to, before manufacturing, we'll be doing lot many calculations. Right? So when I'm scaling down that particular prototype, that is the actual product, that means it is a becomes a model. Okay, an actual product can be represented in the terms prototype. Okay? So please do remember the points which I have explained right now, the numbers. Please go through them, and evening we will solve the problem based on the problem and based on these dimensions. And the same note we will also see for the potential flow. Okay, we will also move for the potential flow, where we will see the uniform flow, uh, then this vortex flow, right? And the combination of all the flows, doublet flows, source flow, sink flow, and the problems based on that. All right.
Excuse me, ma'am. I have a small doubt. I want to ask one question, ma'am.
Yes, please.
And it's pertaining to yesterday's test, ma'am. Question
Yes,
number, yes, ma'am. I guess it's question number 9 or 4. I'm not so sure of the question number, but it's regarding the velocity. I mean, it's a u and